Ronald Reagan once said that nothing is truly impossible because there are no limits to human creativity, imagination, and wonder. Since the dawn of human history, we would look to the sky and yearn to have the same graceful abilities as the birds, eagles, and the swans soaring above us with ease. Many wishings, yearnings, and aspirations throughout human civilization have all been made possible through scientific discovery, community, and scientific advancement. Throughout thousands of these years, up until the invention of the airplane, it only took 60 more years until humans landed on the moon. Shout out to Neil Armstrong and Buzz Aldrin. In the present day, now we have an extremely complex system of modern communications around the world called the Internet. What kind of new technologies and advancements can we expect to become commonplace in the future if these advancements keep happening so rapidly from here on out? In this video, Science Explained is going to bring you an awesome explanation on the scientific possibility of jetpacks, or an armored flight suit, so to speak. Stay tuned, don't forget to subscribe, and let's jump right on in the video. A jetpack is a device that allows a person to fly by providing thrust and propulsion. The physics behind a jetpack involves the principles of Newton's laws of motion and the conservation of momentum. Most jetpacks use a propulsion system that involves the ejection of high-speed exhaust gases to generate thrust in the opposite direction. This action follows Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. The force exerted by the ejected gases propels the person wearing the jetpack in the opposite direction. To understand how a jetpack generates thrust, we need to consider Newton's third law of motion. It states that for every action, there is an equal and opposite reaction. When high-speed exhaust gases are ejected backward, an equal and opposite force is exerted on the jetpack wearer, propelling them forward. The magnitude of the thrust force can be calculated using the equation thrust equals sign, mass flow rate x exhaust velocity, where the mass flow rate is the rate at which mass is expelled, and the exhaust velocity is the speed at which the gases leave the nozzle. Increasing either of these factors will result in greater thrust. As mentioned earlier, the principle of conservation of momentum is essential in understanding how a jetpack works. Momentum is the product of an object's mass and velocity. When the jetpack expels gases with a certain mass and velocity, it gains an equal but opposite momentum in the forward direction, causing the wearer to move in the opposite direction to conserve momentum. Mathematically, the conservation of momentum can be expressed as mass of gases x exhaust velocity equals sign mass of person plus mass of jetpack, x velocity of person and jetpack. This equation illustrates that the momentum gained by the expelled gases is equal to the combined momentum of the person and the jetpack. Certainly. Let's explore the control and stabilization of a jetpack in more detail, incorporating relevant equations and physics concepts. Thrust vectoring. Thrusters on a jetpack can be angled or rotated to change the direction of the exhaust gases, altering the thrust vector and allowing the user to control the jetpack's movement. This principle is based on the conservation of angular momentum. Angular momentum, L, is the product of an object's moment of inertia, I, and its angular velocity, omega. When a thruster changes its direction, the angular momentum of the system must be conserved. The equation pho angular momentum is L equals sign yx omega. By changing the direction of the thruster, the moment of inertia, I, and the angular velocity, omega, are modified, ensuring that the angular momentum remains constant. Control surfaces. Control surfaces, such as wings or flaps, are used in some jetpack designs to provide stability and maneuverability. They operate based on principles of aerodynamics, similar to those used in aircraft. Lift equation. The lift force, L, generated by a control surface is given by the lift equation, L equals sign 0.5 xRO x V2 x AXCL, where RO is the air density, V is the velocity of the jetpack through the air, A is the control surface area, CL is the coefficient of lift, which depends on the control surface's shape and angle of attack. This equation states that the lift force is proportional to the air density, the square of the velocity, the control surface area, and the coefficient of lift. Control moment. Control surfaces also create moments which affect the rotational motion of the jetpack. The control moment generated by a control surface is given by m equals sign 0.5x ROx V2x AX CLXD, where m is the control moment, d is the distance from the control surface to the jetpack's center of mass. The control moment influences the jetpack's rotational motion, allowing the user to control the roll, pitch, and yaw of the jetpack. By adjusting the control surface's angles and positions, the lift and control moments can be manipulated, providing stability and enabling controlled flight. It's worth noting that the specific equations and control mechanisms can vary depending on the design and configuration of a particular jetpack. Engineers and designers optimize these factors to achieve the desired control and stabilization characteristics, while considering the weight, size, and aerodynamic properties of the jetpack. Let's delve into the concept of energy in the context of jetpacks, including conservation of energy and the concept of work. Conservation of energy. The principle of conservation of energy states that energy cannot be created or destroyed. It can only be transferred or transformed from one form to another. This principle applies to jetpacks, where energy is transformed from its initial stored form into the kinetic energy of the person and the jetpack during flight. In a jetpack, the energy is typically stored in a fuel source, such as kerosene or hydrogen peroxide. When the fuel undergoes combustion or chemical reactions, it releases energy in the form of heat and high-pressure gases. This energy is then converted into kinetic energy, propelling the person and the jetpack forward. Throughout this process, it's essential to minimize energy losses due to factors such as friction, heat dissipation, and inefficient propulsion. Designing an efficient jetpack involves optimizing the energy conversion process and minimizing energy losses to maximize the amount of useful work performed. Work is the transfer of energy that occurs when a force acts upon an object, causing it to move. In the context of a jetpack, work is done by the propulsion system to overcome gravity and air resistance, allowing the person and the jetpack to ascend and move through the air. In the case of a jetpack, the force is the thrust generated by the propulsion system, and the distance is the distance traveled by the person and the jetpack. By performing work, the propulsion system imparts kinetic energy to the person and the jetpack, enabling them to overcome gravitational forces and air resistance and achieve flight. Efficiency plays a crucial role in the work performed by a jetpack. A more efficient jetpack can convert a higher percentage of the stored energy into useful work, reducing energy losses and optimizing flight performance. By understanding the conservation of energy and the concept of work, engineers can design jetpacks that efficiently convert stored energy into useful propulsion, allowing individuals to experience powered flight while minimizing energy waste. In summary, the physics of jetpacks is crucial for engineers in designing and optimizing these devices. Principles such as Newton's laws, conservation of momentum, and the concept of work guide the development of propulsion systems, control mechanisms, and energy efficiency. By understanding and applying these physics principles, engineers can create jetpacks that offer controlled flight, efficient propulsion, and pave the way for personal aviation. Jetpack technology holds immense potential in various fields and captures our imagination by bringing the dream of flight closer to reality. Thank you for watching. It was a pleasure for us to make this video and have you as our viewer. Don't forget to follow and subscribe to us so you can watch more of our videos later. Stay tuned.